Welcome to a new test, repair and teardown video. This time I got another HP product, 6825A. This is a Bipolar Power Supply / Amplifier. So this means you can input something, it will amplify it, and so it's actually like a DC coupled power supply that will amplify from 0 Hz to 40 kilohertz. So that's pretty cool. In DC voltage mode, now we are in DC voltage mode. I connected a voltmeter. So let's see. Let's lock the range here so it's easier to see. So this is positive voltage, negative voltage. The fun thing is it's not completely symmetric, so it goes -20, +23, and I think that's actually normal. So that's a little bit weird. The meters are like really accurate, so like that's pretty good. So far it seems to be working. I can get voltage out, and that is actually where all the fun stops. Because obviously I get stuff that is defect, or people don't want it, or they send it to me for some kind of funny things here. So there is a problem with the current. So I gotta, of course this is doing positive, negative, so I don't really dare to put this on a normal load. So what I'm doing is I'm just putting in on a big variable resistor. So that should be easy. It's actually a little bit inductive, and that is also what this cannot like. Don't really like it. So I put this in the middle, so it's like 50 ohms. It shouldn't do a lot, should it? Meter is, see, 2.5 amps, full throttle on the current limits. Voltage is just 5 volts, and then oops. See? That is not good. And we don't really get any current, right? And it doesn't really seem to be... See? That tells me something. So it has something to do with the way that the current is measured or controlled, because there's no response whatsoever on the setting. And also a fun thing, when I increase the resistance, obviously voltage goes up, right? Remember, if it's open, I get my 5 volts and everything is perfectly in regulation. But what happens if... Ooh, that is weird, right? At some current, or at some load, now it's 100 ohms. Voltage is higher. Ooh, that is not nice. So now I connect 100 ohm, and voltage goes up. Ooh, that is bad, right? And of course, if I... See? All the way to 0, I can of course short circuit the damn thing. Still no response whatsoever. No. We need to open and investigate. That is a little bit of a surprise to find that big a transformer. Are you kidding me? It is humongous. Look at my hand here, how big it is. But it's also quite heavy, so... Wow. And the heat sink is like solid. Wow. I feel a little bit of a greasy... So maybe there is a capacitor. Or maybe it's... Yeah, this is sticky. Maybe we got some blown up capacitors. I was actually looking for the current sense resistor because I think that somebody blew up the current sense resistor by inputting some stuff that was too powerful or something like that. But I guess we can maybe take off the sides and easier access everything. There's also a board in the bottom, so that we also need to inspect. But so far it looks really beautiful. Oh, there's a socket down there, so we can easily pull up the boards. I like that. That is great for service. So the first thing we're gonna do is go through everything in quite good detail visually, just to see if there's anything that pops up, because it's just the easiest thing to do, so why not? This design should be from about 74, so I'm looking for date codes on some of the chips here, and I see 79 on almost everything, so that means this is a lot newer model. It's not from the very early, but of course they manufactured this over quite some years. And this is the bottom part. There's a little solder splat there, and maybe somebody replaced. A little bit brown, but other than that I don't really see anything bad. That will be the wires to the power transistors. I can see some power transistors down there. They're of course mounted real good to the heat sinks. They're not that easy to access. Let's hope it's not a power transistor issue. And this is the current sense resistor. This is probably 0.5 ohm. That is exactly what I'm looking for. So this one I need to measure. And we've got some diodes around this, the current sense stuff, or maybe it's those, or we'll see. I found the schematics, so that is really good. Got a lot of well, is this op amps or stuff like that, I guess. So it's probably in the current sense kind of stuff. Yeah. We'll see what is going to happen here. What is that switch doing? I have no clue whatsoever. So that pot meter is the current settings, and that is what it's not responding on, right? So what I found out is that pot meter is connected here, and we got some resistors and stuff here. So that means those wires go here to this connector, and that connector is a flat cable. What's right there? And this flat cable go here. See? There's that one. It goes to the back, and there's a PCB here with some stuff, and that is a little bit odd. Look at that. A lot of stuff, you don't know what that is. And we've got some sense and things, and that is connected correctly, I guess. I think half of the other things, that will be voltage selection for our mains, because this is the kind of warning stuff. So I need to consult the manual again and see if everything is connected correctly here. So everything is connected correctly on the rear. I've been thinking a little bit more before I dig into it deeper. It's always good to investigate much more deeply on the front panel what is working, what is not working. So here's what I do. Let's go to plus 5 volts again, just to show the difference. So here's 5 volt, and I come with 100 ohms, and it goes a little bit positive. Okay, so now I change the resistance down to a point where the voltage just goes down a little bit. All right, so now it's I remove the load. But now I go down to minus 5 volts. Okay, let's try and put the load on again. Ooh, so it goes positive. That is funny. And I don't see any current consumption or anything bad happening here. It's 13 watts of idle in both cases, so nothing bad is going on. So I think I'm going to consult the schematics a lot deeper. Oh my gosh, after I've been tracing around with ground. So ground is supposed to go to the 0.5 ohm current sense resistor, right? And this end of the resistor is directly connected to ground. That output is supposed to be directly connected to the low output. All right? But if I measure voltage between this point and that point, I see 0 volts and everything is fine. Then I try to load a little bit on the output, and remember, this thing can't handle any loads, and then it goes crazy. Ooh, then I see 20 volts between those 2 points. So then I was tracing. Ooh, is it this via? Oh, this signal goes straight out here. Fantastic. And this board sits like this, right? And then there's a track here that goes blah 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 here, and there's a wire that goes to this point. So where the heck is the error? So I was looking down here. Hoo-yoo-yoo. What is that for a shit, man? This wire is falling off. It was supposed to be on that one, right? Because you see, we got 2 wires, and that is the sense wire, or the output wire thingy that is lost. I'm gonna solder this on there, and it's gonna be solved. Definitely. Ha ha! Winner, winner, man. Okay, well, let's not celebrate until we see it works, but I think I will call this a half a celebration. Oh, you need to see this. Look at that. It works. And let's go positive. See, no more problems. So that will be a 2.4 amp positive. How about we just give it an amp, right? Let's try and poke with the. Ooh, we're in current mode. Ooh, why don't we see this light up? That LED is not working, but current seems to be working. Let's dial this down to a half an amp and then remove the load. No, the LED is not working. And then let's go negative. So that will also, yes. So that means current. That's a little bit weird. So you dial it down for negative current. Huh? That's a little bit funny. So that means 0 current, right? And this means a lot of current. This means 0 current, 0 volts. I go positive. Yeah, okay. And then I can get some more amps. Alright. But why isn't this... What am I doing wrong? Okay. So we need to go in the ×4. Can you hear some sound? So that's 16 volts, 1.6 amp. No, I can't give it any more. Give it more. Yeah, baby. So that's 20 volts and 2 amps. So that's a lot of watts. hear some zzz. Can you hear it? This can't be good. Is this normal? Really? I need to put a scope on this and measure. Same sound for negative. Yeah. Well, the thing is working. I am happy. Let's call this for celebration. Just measuring a little bit more. So this is with load, you can hear it, and without the load. So that means the ripple that we see is actually the same. So that means the main capacitor is not the problem. There's an auxiliary voltage, so it's a little bit full of ripple, I guess. See, and if I go down to 0, it's the same. So now there's no load, no nothing, and we still see a little bit of ripple. It's not like 20 millivolts or something like that. It's really not a thing. And you see it's quite touchy, obviously. What you see there is I'm in AC, so every time I change the voltage, or obviously, see, that's just the pot meter changes, and then it goes into regulation. Obviously, it got the regulation loop is 40 kilohertz, so it is designed for 0 to 40 kilohertz. So that's why it's quite fast. But anyway, yeah, it works, and current mode works perfectly fine. I was just missing this LED, so it's just a matter of changing that one, and it's gonna be fine. All right, happy. Good night. Sleep well. I have to investigate the current limiting feature all the way to the end, and there's this LED. That's the only thing that is not working. See, when I'm doing current limit by overload, the LED is not going on. And that is actually a really useful feature when you see this as a user side kind of thing. So this is Q2 and Q3, and also down here is Q4 NPN transistors, all of them. What I find a little bit odd in this part of the schematic is Q4 base is connected directly to Q2's base. So what if they are a little bit different? That means one will go on and the other one can't go on. So that is a little bit of a not so cool design. I don't see those kinds of things normally. That is not so good. But see, the first thing I want to do is take Q2 and short circuit the base to its emitter to prove the LED goes on. So this verify Q2 and Q3, and I also measured on Q4, that is the current limits output status transistor. This is all it does to the output side, and that one also switches fine when I do this trick. So that means all those 3 NPN transistors, they work perfectly fine. So here's what I did. I removed Q5 and Q6, and I put in 2 new ones, and of course it's working. So this is what they mounted, and they're completely shorted, so nothing works. And that is of course only in the indication, because the 2 current regulation op amps, they of course gate perfectly together with some diodes, and then they pull down the voltage and all that. We have already seen that works. So now we're having a negative voltage and we overload it. See, now the LED goes on. And then of course you need to do the same test with a positive voltage, and then go into current mode, and then you see the LED works. So I'm so happy all features works now. Let me just explain this in a few seconds. Let's look at the schematic. I had to redraw and assemble the schematic from a few sheets just to make it a little bit more clear what is going on. See, this is the current sense resistor I'm talking about, and this is the ground output, and the ground output is on the other side of this current sense resistor, connected to the 0 volt, the midpoint of the capacitors. So this system measures the current, and here we have the current settings, and all that is here. And we've got two different, let me zoom in here, we've got two different current op amps. They are divided into a positive side and a negative side, and they're gated together with these two diodes. It's very, very difficult to see on the schematic. I'm sorry about this, but this is just how it is. And it's easy to measure on pin 6 and pin 6 of the two op amps, that each side actually works. But of course we already knew that, because we know this output goes to the voltage system and it does actually work. What is not working is the current flags, or the LED. So let's go back to the LED. Here is the LED for current mode. That one didn't work. So of course it's a very old LED, so we need to just test the LED first. And it's easily done by just short circuit the base of Q2 to its emitter, and then of course the LED goes on. And the cool thing about testing stuff in the middle of a circuit, see, that was two transistors and then LED. That is, of course, you save a lot of work, because that, okay, now we know these two works, and then we can focus on these two that of course don't work, because we know this works. So this is just the fastest way to solve the problem. And it was very easy to measure the signals here, because everything here is completely shorted. Nothing works here, so that is perfectly fine. Put in two new transistors and it works. I also drawn this schematic a little bit more beautiful, so you can easier see what is NPN and PNP. The original schematic is in this kind of state, and this is actually a good one here. You can actually see what kind of transistor this is. Q1, and this diode is not mounted in this model, and this is a fold back. As you can see, when either the positive or negative is active, it will activate Q1 and it will move the point, the set point, so it will stay in a fold back system. So if you want fold back, of course you need to mount this again. And yeah, this was also a little complaint I had about Q4 and Q2. See, two base directly connected together and two emitters connected directly together. This is not how I recommend to design a circuit. So please don't copy any ideas from this. This is not good style. Imagine one is a little bit colder or hotter, or is loaded differently or whatnot. Then you're going to have one that is working and one that is not working.